Hey students, this is a video on section 14.4, the chain rule. Because these problems are so long, I'm only going to have time to do one of them, but I will try to do one problem in full detail. Hopefully you've already watched the videos on dependency diagrams, because we are going to use those here. Okay, so let's take a look at this example. Okay, example. Consider the functions z equals -3 times e to the x ln of y. Z equals -3 times e to the x ln of y. Okay, x equals ln of u cosine of v, okay? And then y equals u sine of v. This was about the hardest one I could find for my example, so I tried to choose a challenging one so you could see hopefully all the tricks. But remember, you have my formulas from Calculus 1 and Calculus 2. That's in probably my week 9 or week 10 module, depending on which of my courses you're in. But you can always look them up on Google as well. Okay, so we've got z equals -3 e to the x ln of y. And then we have x equals ln of u cosine of v, and then y equals u sine of v. And they want us to calculate partial z partial u and partial z partial v. Okay, so calculate partial z partial u and partial z partial v. Okay? And there's two ways you can do this. One way is to plug everything in directly, which is pretty challenging. And the other way is to do the chain rule. And either way is fine, but I'm going to show you how to do both ways. Okay, so let's start with method 1, which is going to be the chain rule. I'm going to call it method 1. Okay, so method 1 is use the chain rule, which is the title of the section, so it seems good that we're going to be doing that. And for that, we're going to have to do a dependency diagram. Okay, so we're going to draw a dependency diagram. Sorry, I'm having trouble with my pen right now. Maybe I'm writing too small. Yeah, let me scroll down here. So we're going to be doing the chain rule, and we're going to do the chain rule using a dependency diagram, just like the other videos that I made. And so let's do a dependency diagram for partial z partial u. So for partial z partial u, dependency diagram, we start on the top, which is at z, and then we draw our diagram. So z is a function of x and y. So because it's a function of two variables, z is going to split into two variables. So it's going to split into x. It's also going to split into y. Okay? And then since we're doing partial z partial u, x is a function of u and v, and y is also a function of u and v. But since we're doing partial z partial u, we're going to end our dependency diagram at u on the bottom here. Okay, so down here we're going to end at u. All right, and then we just go ahead and starting at the top, we work our way down, writing down the partial derivatives. So our first one is starting at z and ending at x. So that first one on the left side is going to be partial z, partial x. Okay? And then going from x to u, from top to bottom, this next one is going to be partial x, partial u. And remember, u is a x and y are functions of two variables. So we're going to actually have a partial derivative here. Okay, so, and then on the right side we do the same thing. So from top to bottom we have partial z, partial y. And then we have, on the right side going down here, we have partial y, partial u. Okay, so that's going to enable us to write out the chain rule. Okay, so the chain rule is going to be using this dependency diagram. Well, first we trace down the left side. So we've got partial z, partial u equals, well, tracing down the left side of this diagram, starting at the top, we have partial z, partial x times partial x, partial u. Okay, partial z, partial x times partial x, partial u. That's the left side of the dependency diagram. And then on the right side, we do the same thing. We start from the top and we trace our way down to the bottom. So that's going to be partial z, partial y times partial y, partial u. Okay, so plus partial z, partial y times partial y, partial u. And then when you're doing the chain rule like this, obviously you're going to have to calculate a lot of partial derivatives. But they've given us the information we need here. Okay, so they've told us what z, x, and y are. So we're just going to work through these. So let's start with partial z, partial x. Okay, so partial z, partial x. Well, going back up to the definition of z, z equals negative 3 e to the x times ln of y. So partial z, partial x means we treat y as a constant. So the only thing we're taking the derivative of here is the e to the x. And remember, the derivative of e to the x is e to the x. So this is actually still going to be negative 3 e to the x times ln of y. Okay, so negative 3 e to the x times ln of y. So that's our partial z, partial x. That's that one right there that we calculated. Okay? And remember, when you're taking a partial derivative, the other variable is constant. So that's why y was constant there, because we were taking the derivative with respect to x. Okay? And then for the next one, we're going to do partial x, partial u. So let me do that in a different color. So for partial x, partial u, we have to scroll back up again to the top. So they said x equals ln of u cosine of v. So partial x, partial u means we're going to have to use the old chain rule here. So first we're going to have to take the derivative of the outside function, inner function left alone, and then multiply that times the derivative of the inside function. So here, over here I can write it. Partial x, partial u. Well, the derivative of the ln, which is the outside function, is 1 over. So that's going to be 1 over u cosine of v. And then we multiply this times the derivative of the inner function. So v is a constant here. So that means cosine of v is a constant. So we're really just taking the derivative of the u. And the derivative of u is 1. Okay? So we're going to have 1 times cosine of v, which is just cosine of v. So for partial x, partial u, you should have 1 over u cosine of v times cosine of v. And the cosine of v's cancel out. So partial x partial u is actually just going to be 1 over u. Okay? So let me write that down here. Partial x partial u equals 1 over u. Alright, and I'm probably going to run out of colors before long, but let's go ahead and do partial z partial y next. Okay, partial z partial y. Okay, so for partial z partial y, we said z equals negative 3 e to the x ln of y. So partial z partial y means that x is constant. So we're literally just taking the derivative of the ln of y, which is going to be 1 over y. So this is going to be negative 3 e to the x, because that's all constant, times 1 over y. So we're going to have negative 3 e to the x over y. Okay, so partial z partial y equals negative 3 e to the x over y. Alright, and then for our last derivative that we have to calculate here, partial y partial u. For that one, we know that y equals u sine of v. And I'm kind of out of new colors here. So I guess I'm just going to go back to, I guess I'll go back to black. So for partial y partial u, let me do that one over here. Partial y partial u. We know that y equals u sine of v, and since we're doing partial y partial u, the other variable is constant. So v is constant, which means sine of v is constant. So we're literally just taking the derivative of u, which is 1. Okay? So partial y partial u is actually just going to equal sine of v. Okay? So this is the chain rule. It takes a long time to do all the derivatives. It's a bunch of little parts. But this is going to enable us to find partial z partial u. So if we plug everything in here into the chain rule diagram, into the chain rule formula, we're going to be able to calculate it. So partial z partial x, we said, was negative 3 e to the x times ln of y. Partial x partial u was 1 over u, so this is times 1 over u. Okay, and then we add this to partial z partial y. So we're going to have plus negative 3 e to the x over y times partial y partial u. So that's going to be sine of v. Okay? And then this one right here is actually that whole mess there is partial z partial u. This is partial z partial u. Okay, so these are a lot of work. That's like why I said I'm only going to be doing one example. So, so we're good so far. Okay, so believe it or not, that was a lot of work, but we still aren't even finished doing it with the chain rule, because you're not supposed to express your answer in terms of, well, here we have it expressed in terms of 4 variables. That's our partial z partial u, but we actually have to plug back in so that our answer is just in terms of the final variables u and v. Okay, so express your answer in terms of u and v. They actually said that we had to do that in the directions. I just didn't write it down because I already had too many directions to write down. Okay, so you would think that you'd be done here after doing all those partial derivatives, but you're actually not. So what you have to do is you have to plug in for x and y in terms of u and v. But it's not as bad as it sounds. So we already know that x equals ln of u cosine of v. Okay, so we're gonna plug in x equals ln of u cosine of v. Okay, and then we're going to be plugging in y was u sine of v. Okay, so we're going to plug in y equals u sine of v. Okay, so that's why I'm only doing one example. It's ridiculously long. So plugging those in here, we're going to have quite a mess. So the negative 3 e to the x ln of y, plugging in, now we're going to have negative 3 e to the x, which is ln of u cosine of v, okay, times ln of y, so that's going to be ln of u sine of v, ln of u sine of v, oh, I didn't write it very well. Let me write that so it's more readable. So we have negative 3 e to the ln of u cosine of v times ln of u sine of v, okay, times 1 over u, times 1 over u. All right, and then we have a minus 3e to the x, so that's going to be minus 3e to the, well, we said x that we're plugging in is ln of u cosine of v, so it's going to be e to the ln of u cosine of v all over y, and then we said that the y that we're plugging in was u sine of v. So this is over u sine of v. Okay? And then this whole thing is times sine of v. So we also have a sine of v out here. So these get very messy. And some people actually prefer to not do the chain rule because it can get so long and messy, particularly in this step. But stuff is supposed to cancel out. So let's look over here. We know that e to the ln, that cancels out because they're inverses. Okay, so for this first one, we're actually going to have negative 3 u cosine of v times ln of u sine of v times 1 over u. So this is all over u. So I can actually cancel out those two u's. So that's going to leave me for my first term, and I'm going to have negative 3 cosine of v times ln of u sine of v. Okay? Because the u's cancel. And then for this second term, we can simplify this one as well. So once again, we have e to the ln. So the e and the ln cancel out. So we're just going to have negative 3 u cosine of v times sine of v all over u sine of v. But the sine of v's are going to cancel and the u's are going to cancel. So we're going to be left with negative 3 cosine of v. So after doing all that work, we can still simplify it a little bit more. So notice we have a common factor of negative 3 cosine of v for both of these terms. So we can actually factor that All right, so what we got here is partial z partial u, partial z partial u equals, well, if we factor out the negative 3 cosine of v, we're going to have negative 3 cosine of v times the quantity ln of u sine of v plus 1, because there's still a 1 left over. All right, and believe it or not, that's exactly what they have written on my math lab. So we did it all right. But it's obviously a very long process. So that's using the chain rule to find partial z partial u. And once you have partial z partial u, you can also plug in numbers. They're going to have you do that on your homework. Okay, so that was the chain rule method for partial z partial u. And so that's method 1. And they also wanted to do partial z partial v. So for partial z partial v, I'm going to use method 2, because I don't want to do 4 of these. There's not enough time. So for partial z partial v, I'm going to use method 2. Just to explain it to you. Okay, so method 2. For method 2, basically what you do is you express everything in terms of u and v right at the beginning. Okay, so express the function in terms of u and v only. Okay, then take the derivative. And on a lot of problems, this is actually faster than the chain rule. Okay, so often faster than the chain rule. It's just sometimes the derivatives can get so hard to calculate that you have to use the chain rule. Okay, so we use method 1 for the first derivative that they asked us to find, partial z partial u. So for partial z partial u, we used method 1. And then just to show you method 2, I'm going to do method 2 for partial z partial v. But when you're doing your homework, you can use either one you prefer. It's just they're going to ask you for different parts of each one, so I have to show you how to do each one. Okay, so we're going to do method 2, and for that one we're going to be finding partial z partial v. Okay, so for partial z partial v, we're going to need to express z in terms of just u and v. Okay, so express z in terms of u and v only. All right. So we had the definition of z up here. So z equals negative 3 e to the x ln of y. Okay, so we know that z equals negative 3 e to the x times ln of y. Now we have to get rid of the x and the y, so we're going to go ahead and plug in for x in terms of u and v. Okay, so for x, we said that x equals ln of u cosine of v, so we're actually going to be plugging that in for x. Ln of u cosine of v. So we have negative 3 e to the ln of u cosine of v. Okay, and then for ln of y, for ln of y, we need to plug in the expression they gave us for y in terms of u and v. So they told us that y equals u sine of v. So we're going to be plugging in u sine of v for y. Okay, so we have ln of u sine of v. Sorry, wrong color. Okay, so with method 2, what we're doing is right at the beginning, instead of having to do all these partial derivatives, we're getting the original function, z, in terms of the final variables. So we're expressing z in terms of the final variables u and v only, and that's going to make it so we have to do a lot less work than the chain rule. Of course, sometimes it's impossible to do it without the chain rule, so that's why we're learning the chain rule. But in this case, it's actually probably going to be quicker. So anyway, what's going to happen here is the e to the ln, those are going to cancel out. Alright, so we're actually just going to have negative 3 u cosine of v. But nothing else really cancels out. So we have negative 3 u cosine of v times ln of u sine of v. So this is our z. And as part of your homework, they actually ask you to express it this way. So you have to be comfortable with doing both method 1 and method 2 to do your homework. Okay. But it looks like we got the same answer as them, so we're on the right track. So what we're going to do now is, for the other part, we did partial z, partial u. So for this one, we're going to be doing partial z, partial v. And here we don't need to use a dependency diagram. Since we've already expressed the function in terms of just u and v, we can go ahead and just calculate the partial derivative directly. It's just going to be a little bit messy. So partial z, partial v is what we're going to calculate. And remember, the other variable is constant. So here, since we're taking the derivative with respect to v, that means u is constant. Okay, so since u is constant, we're really only taking the derivative of the expressions involving v. But there's a lot of them, and it's kind of messy. Okay, so we're going to have our work cut out for us. But for the negative 3 cosine, the negative 3u, that's going to be a constant, but the cosine of v is not a constant. So what we're going to have to do here is we're actually going to have to use the product rule. Okay? So I'm going to call this first one f, and the second one g, and then we're going to use the product rule. Okay, so that's going to be the product rule says that you have the first thing times the derivative of the second thing, so that's going to be f g prime plus the derivative of the first thing times the second thing, so plus f prime g. Okay, so for that we're going to have to calculate f prime and g prime. So here f is negative 3u cosine of v. So that means for f prime, we said that u was constant. So the derivative of negative 3u cosine of v is actually going to be negative 3u times negative sine of v. Negative 3u times negative sine of v. So the minuses are going to cancel. So f prime is actually going to be 3u sine of v. Okay, so there's our f prime, and then we also need our g prime to use the product rule. So for a g prime, we're taking the derivative of ln of u sine of v, and we're taking the derivative with respect to v. Okay, so u is constant. So using the chain rule, in other words, the old chain rule from Calculus 1, We take the derivative of the outer function, ln, so that's going to give us 1 over u sine of v times the derivative of the inner function. So the derivative of u sine of v with respect to v is going to be u cosine of v, right? Because the derivative of sine of v is cosine of v. So we're going to have u cosine of v here. All right. Cool. So, so far so good. All right. So then to finish this, what we got to do is we got to plug all this stuff in and simplify stuff a little bit. So here the u's cancel out, and we have cosine of v over sine of v, which we can write as I think I'm just going to leave it that way because stuff's going to cancel out. So we have g prime equals cosine of v over sine of v. I mean, you could also write it as cotangent, but you don't need to. So plugging everything in here, we've got f g prime, so that's going to be negative 3u cosine of v times g prime, which was cosine of v over sine of v. Okay, cosine of v over sine of v. Okay, and then we have plus f prime g. So that's going to be plus, well, f prime we said was 3u sine of v. So we have plus 3u sine of v times g, and g is ln of u sine of v. ln of u sine of v. So the bad news is it's very complicated when you're doing method 2. There's a lot of different rules you have to use all at once. So if you're not comfortable with calculus 1, some people actually find method 2 harder, but technically method 2 is faster because we're almost to the end of the problem here, and we put in less time than we did on the chain rule one. So here we can just simplify this stuff a little bit. So up here in the numerator we have cosine of v times cosine of v, which is cosine squared of v. Okay, so that's going to give us a negative 3u cosine squared of v all over sine of v plus 3u sine of v times ln of u sine of v. Okay? And let me see if that's what they got. Yep, negative, they wrote the order different, but they still got the same terms as we did. So we're good there. Okay, so that thing that we just found there was our partial z, partial v. So let me label that. This here is partial z, partial v. So I personally like to not use the chain rule because I think it's faster, but you have to be comfortable with doing a bunch of derivatives all at once. So it can be a little bit more complicated for some people, particularly if they're not strong on their calculus 1 and calculus 2. But me personally, I don't like to use the chain rule unless I have to. Okay, but you get to do both on your homework because they'll ask you questions about each thing. So you get to practice each one. And then the last thing that they want you to do is for this problem, they also want you to plug in numbers. Okay, so at the end here, they want us to find partial z, partial u, and partial z, partial v. They don't want you to find it. Actually, I should write it the way they did. They said to evaluate. Okay, so evaluate partial z partial u and partial z partial v at the point u comma v equals 4 comma pi over 4. So as if this problem weren't long enough, at the end they want you to plug in numbers. Okay, but that's pretty straightforward. So I'll just do it for the harder one. I'll do it for, I can do it both. Let's start with partial z partial u. Let's see, where was that? Partial z partial u we did up here. Okay, and it was negative 3 cosine of v times ln of u sine of v plus 1. So if we want to do that one, partial z partial u, evaluate at the point 4 comma pi over 4. We use this notation down here. Remember, the vertical line and then the little point at the bottom means you're evaluating the function at those, where the first one's u and the second one's v. Okay, so we're just going to be plugging in here and then simplifying. So we're going to have negative 3 times cosine of v. So that's going to be negative 3 times cosine of pi over 4 times ln of u sine of v. So that's going to be ln of 4 times sine of pi over 4. Okay, plus 1. All right, and then we can simplify this a little bit. So remember that cosine of pi over 4 and also sine of pi over 4 are both root 2 over 2. So plugging in here, we're going to have negative 3 times root 2 over 2. Actually, I'll just go ahead and move the negative 3 to the numerator. So negative 3 times root 2 over 2 times ln of 4 times root 2 over 2 plus 1. And let's see, they simplified this a little bit. So the 4 and the 2 cancel out, and we get a 2 on the top. And then for our answer, we're going to write it as negative 3 root 2 over 2 times a quantity 1 plus ln of 2 root 2. And that's how they wrote it on my math lab, so we're good there. So that was our partial z partial u evaluated at 4 comma pi over 4. Okay, so I'll go ahead and box that. And then for our last thing, we're going to go ahead and do the other derivative evaluated at 4 comma pi over 4. So the other derivative was partial z partial v, which is up here. Okay, so let's go ahead and do partial z partial v evaluated at 4 comma pi over 4. So that one's going to be a little bit more work because there's so many things going on. But we're plugging in 4 for u and pi over 4 for v. So what we're going to have here is negative 3 times 4 times cosine of pi over 4 squared. Because remember, cosine squared is the same. Cosine squared of v is the same as cosine of v quantity squared. So that's going to be cosine of pi over 4 squared divided by sine of pi over 4. Okay, and then this thing is plus 3u sine of v, so that's going to be plus 3 times 4 times sine of pi over 4 times ln of u sine of v. So that's going to be times ln of 4 times sine of pi over 4. ln of 4 times sine of pi over 4. Okay, so that's our 3u sine of v times ln of u sine of v. Looks good. And then we can simplify this. Okay, so remember sine of pi over 4 and cosine of pi over 4 are both root 2 over 2. So this is root 2 over 2. This one's also root 2 over 2. This is root 2 over 2. And this one is root 2 over 2. Okay, so up here we have root 2 over 2 squared. So we can cancel out the root 2 over 2 with the square, and we just have a root 2 over 2 on the top. And then this 2 cancels out with the 4, and we get a 2 there. So negative 3 times 2 is negative 6 root 2. So that's what we should have left there. Negative 6 root 2. Okay, and then for the second term, the 2 and the 4 cancel out again, and we're left with a 2 on the top. So 2 times 3 is 6 root 2. So we have plus 6 root 2 times ln of, well, inside the natural log, the 2 and the 4 cancel. So we get 2 root 2. So it's going to be ln of 2 root 2. Okay, so we have negative 6 root 2 plus 6 root 2 times ln of 2 root 2. And believe it or not, they actually want you to factor something out here. So they do want you to factor out a negative 12 root 2. And I'm not sure why they factored out a negative 12 root 2, but they did. So I'm going to just do it the way they did. So if I factor out a negative 12 root 2, then I'm going to be left with a 1/2 minus 1/2 ln of 2 root 2. I'm not sure why they factored out a negative 12 root 2 instead of a negative 6 root 2. I don't know if they have a good reason for doing it that way, but that's how they did it on my math lab, so I figured I'd do it the same way they did. Okay, so this is going to be our final answer for partial z, partial v, evaluated at that point. So evaluated at 4 comma pi over 4. Okay, and that's it. We finally finished the whole problem. 43 minutes.